Okay, Assalamualaikum and good morning guys. So this is Foundation Mathematics video for WQD10100. Okay, the title of the video is Cramer Rule. I'm Madam Fauzan binti Abdul Rahman and I teach a diploma program specifically in Foundation Mathematics and for September 2014 semester. Okay, what is cramer rule? Okay, so in the secondary school, we have already covered the cramer rules two times two matrices. Okay, for two times two matrices, we have two equations here. We call it linear system. This is linear system equation. We have two equations, and then we have two variables. So we have variable x and y for first equation. Same with the equation number 2, x and y, right? Okay, we can solve it by using simultaneous equation previously in the class, okay, when we have a substitution and elimination method. But this Cramer rule, we cover the matrices approach. Okay, it's given by the formula x equal to dx. What is d? D stands for determinant. Determinant of the x and determinant of the y divided by the whole determinant. Okay, where d is determinant of d is the determinant and d should be not equal to 0. Okay, this is 2 times 2 matrices, right? So we look at the example of Cramer rule by 2 times 2. Okay, from here we can solve it by using matrix approach. Okay, we can solve by using system of matrix. First, we have to convert this equation to system of the matrix. System of matrix. Alright, so that we can get coefficient matrix 3, negative 4, okay, 2, negative 3. So this is for first, or we call it coefficient matrix, times with the variable matrix, the x and y, right? Then equal to the value matrix, negative 6 and negative 5, right? Okay, this is system of matrix. So what we have to do is we have to find this determinant. So we call it D, right? This determinant we can find from the previous class. Okay, we have determinant 3 times negative 3 minus 2 times negative 4, right? Then we can get 1. Then we have negative 9 plus with the 8, then we can get negative 1. So for determinant, for the coefficient matrix, we can get negative 1. Okay, then we have to find dx. So dx, we have to replace this variable, this column with the value column, so that we can get negative 6, negative 5, with the negative 4 and negative 3. We replace this column to this. Okay, we replace 2 with the negative 6 and 3 with the negative 6 and 2 with the negative 5. Then we have to find the determinant of that. We call it dx. Okay, negative 6 times negative 3, we have to minus with the negative 5 times negative 4. Okay, then we get positive 18 minus 20, then we get negative 2, right? Right. Okay, then we have to find dy. Okay, dy, because we have two variables here. So dy, we replace this column. Now this column with this column, so that we can get 3, 2 for first column, and second column we get negative 6, negative 5. We replace this column with the negative 6 and negative 5. Find the determinant of that. So 3 times negative 5 minus with the 2 times negative 6. Then we can get negative 15, negative, negative, then we get plus 12, then we can get negative 3, right? So from here we can get x equal to dx divided by d and y equal to dy divided by d, right? So x should be, okay, look at to dx, our dx equal to negative 2, our d equal to negative 1. So dx equal to negative 2 divided by negative 1, x should be 2. And y, dy should be negative 3 from the previous calculation, divided by negative 1 is your determinant of the coefficient matrix. Then we get y equal to 3. So x, y you have to put in the matrices. So x equal to 2, y equal to 3. So this is your final solution. Okay. Okay. Now we look at to the Cramer's rule for 3 times 3 matrices or 3 equations with the 3 variables. Okay, so this is example of that. Okay, we go through the example. Okay, straight to the example. Okay, we have 2x plus y minus z equal to 3, negative x plus 2y plus 4z equal to negative 3, and x minus 2y minus 3z equal to 4. So in system of matrices like the 2 times 2 matrices before, we have the coefficient matrix 2 for first equation, negative 1, 1, right? Then for y, 1, 2, and negative 2. And for z, variable is negative 1, 4, and negative 3. So this is coefficient matrices. And variable matrices, we have x, y, and another one z. And the value matrices equal to what? 3, negative 3, and 4. So previously we have already covered the diagonal method to solve the 3 times 3 determinant, right? So you can solve by using that method, diagonal method. Okay, so same with the 2 times 2 matrices, we can find for d first. Okay, d from 3 times 3, 2, 1, negative 1, negative 1, 2, 4, 1, negative 2, negative 3. So you have to use diagonal method. So 2, negative 1, 1, 1, 2, negative 2. Okay, find this by using diagonal method. We can get 2 times 2, 4, negative 3, negative 12, plus 1 times 4, 5 times 1, plus 4, negative 1 times negative 1, 1 times negative 2, negative 2. Okay, minus with another direction. Okay, 1 times 2 times negative 1, we can get negative 2. Negative 2 times 4, negative 8 times 2, negative 16, right? Then negative 3 times negative 1, 3 times 1 plus 3, right? Then we can get 12, negative 12 plus 4, then we can get negative 8 minus 2, negative 10, right? Okay, minus with the negative 2 times 8 minus 16, negative 18, plus 3, negative 15. So that we can get negative 10 plus 15, then we can get 5, right? So this is your D. Okay, so we have to find dx, dy, and dz. Okay, dx, dy, and dz. Alright, we have to find dx, dy, and dz, right? Okay, so dx Okay, we have to replace with the column of x equal to 3, negative 3, 4, 1, 2, negative 2, and negative 1, 4, negative 3. So you have to replace it and you have to use diagonal method. 3, negative 3, 4, 1, 2, negative 2, right? Okay, calculate it. We get, supposedly we have to get 15. Okay, so try calculate at home. Alright, so we get 15, and your dy, we have to replace the second column with the value matrix. Okay, so we get 2, negative 1, 1, 3, negative 3, 4. Then we have negative 1, 4, negative 3. We have to use diagonal method here. So 2, negative 1, 1. You rewrite again the second and first and second column. 3, negative 3, 4. Okay, so use diagonal method you should have, and you calculate it by using diagonal method, and the final answer for d determinant y is negative 10. Calculate it at home too. Alright, so d equal to, okay, so replace matrix value to the third column. So we should get the negative 2, negative 1, 1, 1, 2, and negative 2. Then last column we have 3, negative 3, 4. Okay, use diagonal method here. So 2, negative 1, 1. We write again for first and second column. 1, 2, and negative 2. And this finally we can get for dg equal to 5. Please calculate it at home, right? Okay, so for x should be dx over d. Okay, the previous calculation we have d equal to 5, right? So dx equal to 15. Okay, then 15 over 5, then we can get 3 for x. For y equal to dy divided by d. What is your dy now? Negative 10. And your determinant equal to 5, right? So for y we can get negative 2. And z equal to dv divided by d. What is your dv? Equal to 5. 5 divided by 5 equal to 1. Okay, the final answer you should write in the matrix form. So x, y, and z, your conclusion should be 3. Oh, sorry. You should be 3, 2, negative 2, and 1. So this is your final result for this particular exercise. Alright. Okay. So you can solve the exercise by using the same cramer rule 3 times 3 times. Okay, you can solve it at home. Don't forget to call or meet me at my office if you have the problem. Okay, thank you very much.